All right, so we left off at perform the indicated operations, assume all variables are positive real numbers. So these could be multiplying, dividing, adding, subtracting, whatever the case is. So we're going to start out with one that's adding and subtracting. Number 78, I have 4 times the square root of 18k minus the square root of 72k plus the square root of 50k. So, despite the fact that all of these have a k in them, I can't add them together at this moment because they don't all have the same root, or like what's in the root. So, what I want to do is see if I can get them to be the same so that I can add them together. We have to treat a radical as like an x, where like we have to, in order to add, 3x and 2x, they both have to have that x, and that becomes 5x. So when we think about radicals, that's what we need to do. So I'm going to try to break these down as simple as possible, taking stuff out so that I can combine them together. So I'm going to break down 18k first. Obviously, they each have a k in them. There's only one of them. Those aren't going to come out, so I just leave that. But as far as 18 breaks into what? 2 and 9, and then 9 would be 3 and 3. So you could have broken it down initially either way. But this allows me to take out a 3. So when I rewrite this one, I will have 4 times 3, so that's going to be 12, times the square root of 2k, because 2 is what was left. Now I need to break down 72. How do I break down 72? 9 and 8. 9 is 3 and 3. 8 is 4 and 2. And 4 is 2 and 2. So that means I can take out a 2 and I can take out a 3. And then I'm left with a 2 inside. So this is going to become minus 2 times 3, so 6, square root of 2k, plus, need to break down 50. 50 breaks into 2 and what? 10 and 5. Oh, 10 and 5. I think I did 2. And then 10 breaks into 2 and 5, so I can take out a 5. So that'll be 5. Leave me with a 2 and a k inside, so 5 times the square root of 2k. So now notice that all of these are the same. So I can now treat them as like terms. When I'm adding, I don't add what's inside of them. Okay, I add what's outside of them. So it'll be, essentially I can like cover them up, pretend it doesn't exist. 12 minus 6 plus 5 is 11. So this is going to become 11 times the square root of 2k. So people try to add the stuff inside and be like, it's 6k. It's like, no, we only add what's outside of them. But to add them, they have to be the exact same radical all the way across. Just like we can't add, x cubed plus x squared. That just stays that way, right? But if I have, 2x squared plus x squared, that becomes 3x squared. Like the x squareds don't do anything like weird, right? So we have to treat radicals the same way. Any questions about that? All right, let's see. And it would work the same way if it was like a cube root or something like that, just so you know, like it doesn't just apply to square roots. I've got 86 in the parentheses, the square root of 5 plus the square root of 2 And then the other parentheses, square root of 5 minus the square root of 2. So with this one, I'm foiling, or if you notice the special type and just know how to do that, you can do that as well. Does anybody recognize the special type that this one is? If I gave you like x plus 2, x minus 2. Difference of squares, okay? So if you recognize that, you can do it that way. If not, no big deal. We can just FOIL it. So we will just FOIL it for now. So square root of 5 times square root of 5 is?
2 square root of 5.
Multiply. We multiply what's inside and put it under one radical. So what would that be? Square root of 25. What?
I said 25 at first, then I said it was square root of 5. Back.
Yeah. So then square root of 5 times negative square root of 2. Negative root 10. Square root of 2 times square root of 5. Positive square root of 10. So that's where in our difference of squares that stuff would cancel, so we just wouldn't have written that to begin with if you notice it was a difference of squares. And then lastly, square root of 2 times negative square root of 2. Negative square root of 4. So I've got in here the square root of 10s are canceling each other. What's the square root of 25? And what's the square root of 4? So 5 minus 2 is 3, and that would be your final answer for that. Now, if there's one that is still foiling but not a special type, like this, 4 square root of 5 plus the square root of 2 times 3 square root of 2 minus the square root of 5. I'm going to be foiling this one as well. So 4 root 5 times 3 root 2, what would that be?
12 root 10.
Yep, 12 root 10. So we multiply what's outside and then the stuff that's inside. 4 root 5 times negative root 5.
Negative 4 root 25.
Negative 4 root 25. Then root 2 times 3 root 2.
3 root 4.
Plus 3 root 4. And then root 2 times negative root 5.
Negative root 10.
Negative root 10. And if you see that, like, you know, this is going to be a perfect square thing, you can go ahead and, like, multiply that through in that step without having to go through another whole step. I don't really care. But we'd have 12 root 10 minus, what is that going to become? 20. Plus, what does this become? 6. And then minus root 10. Now I need to combine like terms. So when I combine like terms, I'm combining the numbers that are by themselves, and then I'm combining the 12 root 10 and the negative root 10. So what does that give me?
Negative 11 root 10.
Not negative,
No, positive 11.
but 11 root 10, yes.
And then negative root 10. Minus
14.
14. Yeah.
Yep, so good you didn't try to subtract the 10s inside. Thank you. So I had 12 root 10 minus root 10, so that's like 12 minus 1, so 11 root 10, and then negative 20 plus 6 is negative 14, so this would be your final answer for this one. All right, I've got one more problem. That will probably be the longest one from this section. And then we'll be done. I'll add a couple more problems to what you had yesterday, and then y'all have the rest of the time to work. I've got the cube root of 8m squared n cubed times the cube root of 2m squared all over the cube root of 32 m to the fourth n cubed. So we got a lot happening in this problem. First and foremost, well, there's a couple ways we can go about it. We can either start taking stuff out in groups of 3 since they're all cube roots, or we can go ahead and across like the top multiply those two things together, because that's ultimately what we're going to be doing. So we can multiply what's inside of them and then start taking stuff out. Do y'all have a preference of what order we do it? I really don't care. All right, let's multiply first and then take some stuff out, just so I think it'll save us some steps later on if we do it that way. So if I multiply what's in these two radicals, because I can multiply what's inside, I'm going to end up with the cube root of what?
16m to the 4th. N cubed.
Yep. Oh, not an M, N. And then over the cube root of 32m to the fourth n cubed. So now I would start taking things out as like a group of 3. So what can I take out of the top one? If I need to do like the little factor tree, I can do that. Yeah. Well, I can't take out 4, but what can I take out? I can take out 1, and I'm left with what inside? Yeah, I'll be left with an m inside. So I'm taking out a group of 3. So I've got m. I'm going to leave some space. Inside the cube root, I know I have an m left. What else can I take out? N, and all of those will go away, right? It takes out all of them. What about that 16? How can I rewrite 16? 2 to the what power? 2 to the 4th. So, what can I take out else from the top? A 2, and that leaves me with a 2 inside, right? Now for the bottom, what about that one? What? Take out the 2, is that what you said? And what am I left with inside? How much? What am I left with as far as the 2s? I'm just going to go across in order. 32 is 2 to the what power? So 2 to the 5th power. So I took out a group of 3, so how many is left? 2. So this is going to be 2 squared or 4. So I'm just going to write it as 4. Now what about the m's? I know you were saying that. Take out an m, and what am I left with? M, and what about the ends? Take them all out, so n, and nothing left inside. Now what do I do? cancel. So 2's go away, m's go away, n's go away. So I have the cube root of 2m over the cube root of 4m. So a couple ways I can do this. I can, because it's a fraction, one of my rules says that if I have a radical on the top and bottom, I can write it as one whole radical, and vice versa. So I can do that, or I can rewrite the radical in terms of exponents on each thing and start canceling out exponents that way. I think the easiest way would be for me to rewrite this as the cube root of 2m over 4m. And what is that going to do?
The cube root of 1/2.
Yep, I would be left with the cube root of 1/2 because these m's will cancel. So then I would have the cube root of 1/2. And quite frankly, I'm okay if you leave it there. Some people would tell you that you need to like rationalize it out and stuff, but I would just leave it there as far as that goes, because you're just going to end up with something that's a little more chaotic if you keep going.
Before we start taking out the groups of 3, why couldn't we just divide or like factor out 2 from the bottom one and then get left with? Wait.
We did. I just did it here when I took it out.
Yeah, but couldn't you take only two out of only the bottom and then just like cancel it out and then get left with 1/2?
What do you mean?
Like the bottom, remove half it, and then get left with 16.
Are you saying to have done it like this from the beginning? And then just...
Oh, yeah, pretty much.
You could.
Seems a lot simpler.
Some of them you won't be able to, which is the main reason I worked it all the way down. But if you recognize that you can do that, then that's fine. Yes, it would have gotten you the answer a lot faster. But they won't all be like that, which is the main reason I worked them out step by step, so that you see what to do on the event that it doesn't factor out like that. They're not all nice and pretty like that one. But yes, that would be fine. There are often multiple ways to work a problem, and as long as you get to the final answer and your work isn't just like made up, I don't really care. All right, in addition to the problems you had yesterday, I'm going to scroll back up and add it up here. 77, 85, 91, and 93. You have just shy of 30 minutes to work on this, so I think you should be able to knock it out. Monday we'll review for a quiz on Tuesday, and then what I think is going to happen is Wednesday will be a notes day for starting on chapter 1. Thursday we'll review stuff for chapter 1, and then Friday will be your test, since y'all can't test on Thursday. So that's my tentative plan for you. Could change, but that's what I think we're going to do.